All right, so the final section we are doing is involving double angle identities. So we have done sum and difference, and we know that in order to be able to do those, if we have an angle with two things added together, we have to use a formula to break it apart. A double angle is when you have 2 times an angle. And we can actually figure out these formulas based off the formulas that we've already been using. So the first one, I was just going to show you where one of these came from. I'll put a slide up in a second with all the formulas you need to copy down. So this is just some justification. So a double angle is 2 times something. And we know 2 times something is just when you did a plus a. And then if you use your formula sheet, the cosine of a plus b, that's cosine of the first, cosine of the second, minus sine of the first, sine of the second. So cosine a times cosine a, cosine times cosine, that's cosine squared a. Minus sine a times sine a, so sine times sine is sine squared a. So that is actually our first double angle formula. Now we can use that to get a couple other variations. We know that cosine squared is the same as 1 minus sine squared. So negative sine squared a and negative sine squared a would be negative 2 sine squared a. So this is a second double angle formula for cosine. And the third double angle formula we could use for cosine is if we replaced sine squared with 1 minus cosine squared. Now if you do that, you have to distribute your negative and add like terms. Cosine squared a plus cosine squared a is 2 cosine squared a, and then we have a minus 1. So unlike everything else that has a single formula, with the cosine double angle, we actually get 3 different options. They will all give us the same final answer, and it really won't matter which one you use, but you have that option there. We could get the sine and tangent formulas the same way. I am not going to work those out right now. So here are all of our double angle formulas. Again, we have 3 of them for cosine, and then 1 each for sine and tangent. So pause the video for a moment, write all these down on your packet or in your flip chart, and then once you're done, move on to the examples. So let's take a look at this problem. I want sine theta, or I'm giving you that sine of theta is 2/5 and cosine theta is less than 0. We need sine, cosine, and tangent of 2 theta. So we have to use our double angles. If we look in our formula sheet, sine 2 theta. What is the formula for sine 2 theta? Look at your flip charts. What is that one equal to?
2 sine a cosine a.
So this is 2 sine theta cosine theta. All right, so if I'm trying to figure this out, we're on the right track. We already know sine is 2/5, but I don't know cosine. So I have to figure that value out. To do so, we could go back to this statement right here. Let's set up a triangle like we did way back in the first chapter. Sine is positive, but cosine is negative. So if sine is positive, it's either 1 or 2. If cosine is negative, it's in quadrant 2. So this is for angle theta. So sine, SOHCAHTOA, is opposite over hypotenuse. And we can do Pythagorean theorem to get the other side. So we get 2 squared plus b squared equals 5 squared. When we do a square root, we have to do plus or minus. How do we know if this is positive or negative? I know cosine is less than 0. If you think about this as the x value, if you move backwards, that's a negative. So this side is negative radical 21. So cosine adjacent over hypotenuse is negative radical 21 over 5. When you multiply, these 2's are outside the radical, so I multiply those together, so we get negative 4 radical 21 over 5 times 5 is 25. Is that one okay? So now we need cosine. We have 3 different formulas for cosine 2a. We can pick any of them. Give me a formula you want to use.
Cosine squared theta minus sine squared theta.
So this is cosine of theta. So from my triangle, adjacent over hypotenuse, that's negative radical 21 over 5 squared. Minus sine, opposite over hypotenuse, or it was given, that was a positive 2/5 squared. Negative radical 21 times negative radical 21 is positive 21 over 25. Minus 2 times 2 is 4, 5 squared is 25. So we get that cosine 2 theta equals 17 over 25. All right, tangent 2 theta. We have options. We can use this formula right here. We'll get the tangent A from our triangle and work with it. You can also remember that tangent is just sine over cosine. So tangent 2a is just sine 2a over cosine 2a. Either one will work. If you've already found sine and cosine, it's probably easiest just to divide those. So tangent 2 theta is sine 2 theta divided by cosine 2 theta. If you want to divide fractions, you flip and multiply. So those 25 drop and we get negative 4 radical 21 over 17, which is the same thing you would get if you did the whole formula. Is that okay? Let's try another one. I do want to clarify something. When you get to your homework, if you read the directions, it's going to say find sine and cosine for the given angle, and when you get to the problem, it'll say 2 theta and then have a semicolon and then give you this value. So that just means the same thing. Find sine 2 theta and cosine 2 theta. Okay, so just clarify when you get to the homework, make sure you read those directions so you understand what you're supposed to find. So this time I gave you cosine of theta, and I know sine is greater than 0. Okay, so if I know eventually I'm going to need all these values, so if we set up a triangle, cosine is positive, so that's quadrant 1 or 4. If sine is also positive, then I have to be in quadrant 1. So this is for angle theta, and that's because this was cosine of theta. Cosine is adjacent over hypotenuse, so Pythagorean theorem. Okay, square root. Make sure you can reduce this if you can. 22 only breaks into 2 and 11, so I can't reduce it. But if it were 44, I would want to make sure I broke down that radical. So I can just leave this side as a square root of 22. So sine 2 theta. We only have one formula choice. 2 sine theta, cosine theta. So sine, if I use my triangle, opposite over hypotenuse is radical 22 over 5. Cosine, adjacent over hypotenuse, radical 3 over 5. If I multiply these, the numbers under the radicals get multiplied together. So that's 2 radical 66 over 25. Again, if that radical 66 can be reduced, you need to do so. 66 is not divisible by any perfect square, so that would be my final answer. Now cosine 2 theta. 3 formula choices. Any of them will give you the same answer. I'm going to do a different one than last time. So I'll do 2 cosine squared theta minus 1, just because I gave you cosine theta in the original problem. So cosine squared theta means you find cosine and square it. Cosine is radical 3 over 5. So radical 3 squared is 3 times 2 is 6. 5 squared is 25. So cosine 2 theta turns out to be negative 19 over 25. All right, tangent 2 theta, the easiest option is going to be just to divide these like I did last time. I'll use the formula just to show you how you would do that. But like I said, if you want to go ahead and just divide sine 2 theta and cosine 2 theta, that is perfectly fine. So this was the identity that we copied down. So we have 2. Tangent of theta, opposite over adjacent, over 1 minus tangent theta squared. All right, this one's going to get pretty ugly. So we get 2 radical 22 over radical 3. 1 minus, if I square that, that's 22 over 3. Okay, so if I subtract those, we get negative 19 over 3. To divide fractions, you flip and multiply. So I get negative 6 radical 22 over 19 radical 3. But can't leave a radical on the bottom. So that's negative 6 radical 66 over 19 times 3. And then if you reduce, 6 and 57 are both divisible by 3. And this is the exact same thing you would have gotten if you just divided both of those to begin with. Okay, let's look at this problem. So I've changed it. I'm asking you to find the 6 trig functions of theta this time, not 2 theta. And what I gave you is the cosine of 2 theta. So let's start here. Cosine 2 theta. We have 3 different formulas we can use for cosine 2 theta. If I wanted to find cosine theta, then I might choose to use the variation that involves only cosine. So I could use the 2 cosine squared theta minus 1 formula. So then I know cosine 2 theta, that is 3/4. So if I want to solve, I could add my 1 over. Trying to get cosine by itself, so divide by 2 or multiply by 1/2. And then we have to do a square root. And a square root involves a plus or a minus. So we have to figure out, is it positive or negative? So I go to this. I told you that theta was between 180 and 270. So this is for theta, this is theta. 180 and 270, that's quadrant 3. In quadrant 3, I know cosine is negative. I can't do the square root of 7. 8 breaks into 4 and 2, so that's 2 radical 2. Get the radical off the bottom. So I get negative radical 14 over 4. Because the bottom turns into a 2 square root of 4, so 2 times 2. Now, if I asked you for all 6, I think when you get to the homework, it's only going to ask you for sine and cosine, so they're a little bit nicer. If we have cosine, remember, we can quickly get secant because those are reciprocals. So you multiply by radical 14 on top and bottom. Negative 4 radical 14 over 14, so that reduces to negative 2 radical 14 over 7. For the remaining ones, we could, if I wanted to find sine, I could do a very similar thing. I could take the original and use the formula with sine and get it that way. But it might be easiest, since I already have cosine, I could just set up a triangle. We said we're in quadrant 3. Cosine is adjacent over hypotenuse. So find your missing side. Okay, square root plus and minus, because you're in the third quadrant, that makes this side a negative radical 2. So then sine opposite over hypotenuse is negative radical 2 over 4. Cosecant, the reciprocal, tangent, opposite over adjacent, so you have to get the radical off the bottom. 2 negatives make a positive. So if you multiply by the radical 14, you get the square root of 28 over 14. If you break that down, 28 breaks into 4 and 7, so that's 2 radical 7. And that gives us, radical 7 over 7. And the final one, cotangent, is just the reciprocal of tangent. Is the square root of 7. So I asked for a little bit more on this problem than I'm going to ask you to do on homework, but it's good review, just talking about how we can use that triangle to find all of our values. Okay, I'm going to do a similar example. If you understood the last one, you're welcome to skip this one. If you need it, go ahead and watch it. So I'm asking for sine and cosine of theta itself again. And again, I gave you cosine of 2 theta to start with. So I'm just going to start with the formula. If I want to find cosine theta, I could do the 2 cosine squared theta minus 1. We know cosine of 2 theta is 4/5, so I'm going to replace that with 4/5. So we can add our 1. Divide by 2, or multiply by 1/2. Square root, that means plus or minus, so we have to decide which one it is. And if we look, we are between 90 and 180. So that's quadrant 2. In quadrant 2, cosine is negative. Square root of 9 is 3. We don't know the square root of 10, so we get cosine to be -3, radical 10 over 10. I might only ask for sine and cosine, so you are welcome to set up a triangle at this point to get your sine value. Or, I just want to show you another option. You could do the formula again, but this time, since I'm looking for sine, I would use the formula that involved sine. So cosine 2 theta is 4/5. Okay, subtract your 1. Divide by -2. Square root, plus or minus. Okay, in quadrant 2, sine is positive. Square root of 1 is 1. So we get radical 10 over 10. So two different options. Whether you draw a triangle after you get the first one, or if you just keep solving. Let's try a proof with these. So remember, on our proofs, we always box in one side. We usually try to go with the simpler side, so that might be the right here. So if I'm working with the left, I have to figure out what to do. I notice one issue right away. These angles don't match. These are betas, and this is a 2 beta, so that tells me at some point I will have to use a double angle formula. So if we are looking at the left here, we see both of these are perfect squares, and we are subtracting them. So we could factor that using a difference of squares. Cosine to the 4th would break into cosine squared. Sine to the 4th would break into sine squared. Difference of squares, one gets a plus and one gets a minus. Cosine squared plus sine squared, we know from our formulas that we've used forever, that is 1. Cosine squared minus sine squared, if you look back, that is cosine 2a. So I can use that double angle formula. And 1 times cosine 2 beta is cosine 2 beta. All right, last one. I want to see if we can simplify something like this. So I am giving you 2 cosine squared of 5x minus 1. If you look at your formulas, that's 2 cosine squared a minus 1. And that is the formula for cosine 2a. So in this scenario, a
Question.
So a is 5x in this scenario. So then to finish it, let's just cosine of 2 times 5x, and we get cosine 10x. All right, if I'm looking at b, sine times cosine. Look at your formulas. This is like sine a, cosine a, but we have a problem. The formula has a 2 in front, and I don't have that here. Now, if I had 2 sine a cosine a, that's equal to sine 2a. Since I don't have this 2, you have to think about, it's not here, I have to move it to the other side, so I have to divide by 2, or I'm going to be multiplying this side by 1/2. So this is 2 times 165. So that's a sine of 330. 330 is in quadrant 4. Reference angle 360 minus 330 is 30. So in quadrant 4, sine is negative. Sine of 30 is 1/2. And we get -1/4. Last problem. This one is my tangent 2a formula. And it matches exactly, so I don't have to add a 1/2 or anything in front this time. So my A is 22.5 degrees. So that gives me the tangent of 45 degrees, which is 1. All right, this is your assignment. Trying to keep it short, especially because I wasn't here for your class today. This is due tomorrow, so if you have questions, shoot me an email, pop in tomorrow, come in during advisory. I'm happy to sit down and help you with anything.